then what is left? Rn square and Rn left, so Rn equal to epsilon naught n square h square divided by pi m z square. Okay, this is left. So then again we can write separately Rn equal to, this is constant, we will take all in one side, square, variable is only n square and this is h square. Variable is only n because orbits n, maybe 1, maybe 2, maybe 3 to variable, and z number of positive charge on the protons, so it may vary. So we'll change this one in different side, others constant one will keep one side. So equation number 3. Now putting these values all, what will get? Epsilon naught h square by pi m square is equal to, putting all these values here, we will get, after calculating we are getting one constant value will get 9.1 into 10 to the power minus 31 into 1.6 into 10 to the power minus 19 square is equal to pi, you can take 3.14. okay, 3.14 we can take, putting after calculating all these values you will get 0.53 into 10 to the power minus 10 meter, Rn equal to 0.510 meter. Then Rn, this is equal to this 0.53 into 10 to the power minus 10 meter. So Rn equal to will be what? See, Rn equal to, putting these values in equation number 3 we are getting all here. So from here we will get 0.5 minus 10 into n square z square per meter, this much meter. So equation number 4. okay, this much meter we can get. So this is the deduction part. okay, so again another deduction. okay, I'm just explaining here. okay, so little bit mathematical steps I am showing. okay, so cancellation and all you can do yourself also, by which you can see we can do which way. So equation 4, in any way you can do. Equation 4 gives the radii of orbits in the Bohr model of atom. So n is called what? N is the principal quantum number. N is called the principal quantum number. So this is the diagram. See, if Rn equal to R1, say first orbit. See, it is first orbit, nucleus in the center. So Rn is the first orbit. Then what will be the formula? Formula is getting here 0.53 into 10 to the power minus 10. Then if n equal to 1, first orbit, if n equal to 1, then instead of n you put 1 square by z. So 1 square is 1, so 1 square by z. So what it will be? 0.53 into 10 to the minus 10. The formula will be main formula is what? Nth formula will be Rn equal to n square R1. If this is this one, so formula will be nth one, Rn equal to n square into R1. All this put here, so n square into R1. okay, n square into all this is put the value instead of R1. Suppose here we are putting n square into R1 for Rn, nth formula. So nth formula is like this. okay, because this value is R1 we can write. So like this, if n equal to 1, okay, if n equal to 2 you have to put 2 square, if n equal to 3 square, 4 square, like this it will go on. So this is that they are giving, if R2 equal to 4, R1, R3 equal to 9, R1. okay, this thing. okay, you can write here, and if no time, then you can skip this diagram. okay, up to this much you can give the principal quantum, you just write, and for this value you can write this one, you can skip this diagram. okay, no need to draw, it will take time. okay, so now what is for hydrogen atom? Hydrogen atom you have to find out. Hydrogen atom is what? You just put the value for hydrogen atom. for hydrogen atom now separately we have to see here. I'm not doing, you can do yourself only. For hydrogen atom, okay, for Z equal to, for hydrogen atom Z equal to 1. So what it will be, equation 4 is Rn 0.53 10 to the power minus 10 into n square meter, because Z equal to 1. So if Z equal to 1, then what it will be? What is the formula? We are writing, see, Rn equal to 0.53 into 10 to the power minus 10 for hydrogen atom. For hydrogen atom Z equal to 1, then what it will be, equation 4. This equation 4 becomes Rn equal to 0.10 to the power minus 10 into n square divided by 1, because Z equal to 1. So what it will be, for n equal to Rn equal to 0.53 into 10 to the power minus 10 n square meter, n square meter, okay, n square meter. So now if first orbit, for first orbit n equal to 1, then what it will be, instead of n, R1 0.53 into 10 to the power minus 10 into, instead of n, 1 square is equal to 0.53 into 10 to the power minus 10. 1 square is equal to 1, multiplied by this is 1, same, this is meter, is equal to 10 to the power minus 10 meter is equal to, you can write angstrom. 10 to the minus 10 meter is equal to 1 angstrom. Now R2 equal to, for n equal to 2, R2 equal to 0.53 into 10 to the power minus 10 into, instead of n, 2 square, so is equal to 2.12, multiply these 2 2s are 4, okay, 2 2s are 4, so multiply and do it, 10 to the power minus 10 meter is equal to 2.12 angstrom. 4 multiply by this, you are getting this. For n equal to 3, R3 equal to, formula I just, general formula, from general formula write down, this is constant value you have to write, into, instead of n square you are writing third orbit, so 3 square, okay, 3 square is equal to 0.5 into 10 to the power minus 10 into 9, 3 3s are 9, is equal to 4.77 into 10 to the power minus 10 meter is equal to 4.77 angstrom, okay. Because this is in angstrom, all are in angstrom. So what is this is coming, the radii of first, second and third orbit, allowed orbit hydrogen atom are this 0.53 angstrom, 2.12 angstrom, 4.77 angstrom respectively for hydrogen atom, when your hydrogen atom is in the ground state, Z equal to 1, okay, Z equal to 1, this is atomic number, and ground state is what, this is that, and when n equal to 2, then another one, when n equal to 3, then this is the formula, okay. So these are values of radius of hydrogen atom, okay, from both still we are getting. So up to this much you write down. I'm trying to explain little bit here, okay. If any difficulty you ask me, which portion is not understand, you are not understanding, so I'm trying to explain again. So I think it may be clear. If you do the deduction, you will do once again yourself, so I think it will clear, okay. Mostly here deduction is there, okay. So I'm showing the mathematical steps, I'm sending rough photograph also, you can make a notes yourself and write in your class notes, okay. Next class I'll take another day, okay, bye.